Good morning, students. Today in this video, we are going to see about the second part of Module 1, Machine Instructions and Programs. Let us see about the objective of this particular module. Actually, in this part 2, we are going to discuss about the machine instruction program execution, which includes the branching and subroutine of call and return operations, and number representations of addition and subtraction in the 2's complement system, 1's complement system and 2's complement system, addressing methods or addressing modes for accessing the register and memory operands, assembly language for representing machine instructions, data and programs, and finally we are going to see about the program control input and output operations. Okay, let us see in this module about the particular number arithmetic operations and characters. In general, if you're going to see about that, the number system, first initially is going to be assigned integers. We are going to have three major representations. First one is going to be sign and magnitude, 1's complement representation and 2's complement representation. Actually, we are going to assume that 4-bit machine word, which consisting of 4 bits of data, it may be 0000 to 1111. So that we are going to have 16 different values can be represented to make the 4-bit data. Roughly we can have a positive half of a positive numbers and half of a negative numbers over here. So let's see what is the actually the positive numbers and negative numbers, how we are going to represent a positive numbers and negative numbers. The 16 different values which is going to be taken from 0000 to 1111 in a form of binary, and the same thing can be represented in a form of decimal as 0 1 2 3 4 5 6 7, as well as -0 -1 -2 -3 -4 -6 -7 -8. Different terms we are going to use over there to represent this three major representation as sign and magnitude, 1's complement representation and 2's complement representation. Let us see one by one. Sign and magnitude representation. What actually sign and magnitude representation? The sign and magnitude representation consisting of two direction of data. One is going to have a positive direction as well as negative direction, and its volume is going to be present over there. If you're going to see about this particular diagram, so you can see that the number which is going to be start with +0, +1, +2, +3, +4, +5, +6, +7. Meanwhile, remaining data are going to be taken from -0, -1, -2 until it's going to reach to -7. So this is going to be a decimal representation which have consisting of 0 to 7 in the half of plus and half of minus, whereas the same is going to be represented in a form of 16 different values which has 4-bit data. So if you're going to see about it, 0 is going to be represented as in a binary format of 0000, and 1 is going to be represented with 0001. Like that we are going to represent all the decimal values in terms of 4-bit data. Totally it's going to be consisting of 16 different values. Example, if you're going to see that 0100 is nothing but +4. If you're going to see that, it's going to be an 0100 is going to be +4. Okay. Meanwhile, one more data I'm going to represent that the same -4 can be represented as 1100. Okay. So I'm going to take these two examples over here as 0100 is a +4 representation, 1100 is going to be minus representation. Okay, we are aware about that a 4 is decimal 4 can be represented in a form of binary as 100. Meanwhile, the MSB bit of this 4-bit data, which is going to have a 0 or 1, isn't it? So this 0 represents a positive value and 1 represents a negative value. So it's an example that whenever we are going to see about data which has an MSB bit, the MSB bit is going to be 0, those number can be represented as a positive number, and if the MSB bit is going to be 1, it can be said that it's going to be negative number. Okay, so in such a way we are going to represent this particular number system as sign and magnitude. So this MSB bit represents its sign and remaining bits is representing its magnitude. Okay, such a way we are going to represent this. Always if you're going to see that the higher order bit is going to be 0 means positive and 1 means negative. Okay, so remaining 3-bit data, obviously we're going to say that the 3 lower bit is in the magnitude data. It starts from 000 through 1 1 1 1. Okay, so such a way we are going to have the representation. So if you're going to see that the range, how we can represent the range for an n bits is going to be plus or minus 2 to the power of n minus 1 total minus 1. Such a way we're going to represent that. Okay, two representations for this particular 0 may be minus as well as plus in the sign and magnitude representation. Okay, so sign and magnitude representation is going to represent the values of the value in both directions as positive as well as negative. Totally we are going to have 16 different values, starts from plus 0, minus plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7, and start with minus 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So totally 8 plus 8, 16 different values we are going to represent over there in a decimal format. Equivalence of this decimal format is going to be represented in a form of binary of 4-bit value for each decimal value as 00000 to 1111. Okay, that is, this representation is going to be called as a sign and magnitude representation. Let us see about the second representation, ones complement representation. I hope that you people may aware about this ones complement representation when you come across with the first year first semester basic electronics, in the digital electronics you come across over there, isn't it? I hope you may aware, but even though I'm going to describe that one. Okay, the ones complement representation is going to be mentioned in same value as different terminologies we are going to use over here also. Here what happens, the same plus 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7 up to this, the remaining up to this is going to be same as like the top sign and magnitude representation. Whereas if you're going to enter into the negative value, here we are going to reverse the data as when compared with the sign and magnitude. Okay, here it's going to start with minus 7, minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, ends with minus 0. Okay, this is the major difference between ones complement representation and sign and magnitude representation. Okay, usually what we are going to do in the sense, we are going to make the inverse of the binary representation is going to be made inverse of the representation is going to be called as ones complement representation. To make that appropriate, we are going to represent this plus 0 is nothing but 0 0 0 0. The reverse of 0 0 0 is nothing but 1 1 1 1. So that we are going to represent this 1 1 1 1 as minus 0 in this ones complement representation. And remaining similar to that of the same, if you're going to take the same example, that 0 1 0 0 is nothing but plus 4. Okay, we are going to represent 0 1 0 is going to be plus 4. As already we have come across this, the most significant bit represents the sign of the particular data, isn't it? The bit. So the most significant bit represents 0, so it's going to be a positive number. Okay, so same I'm going to take the negative number of this minus 4. Minus 4 is going to be taken as 1011. I'm going to represent same 1011 here. So 1011, the most significant bit of 1011 is nothing but 1. So this is going to be dealt as a negative number. And if you're going to convert, or if you're going to change the 100 into its one complement, it's going to be 011, isn't it? So that the 1011 is going to represent it as minus 4. Okay, this is the major difference between the signed magnitude representation and ones complement representation. Okay, here what happened, the subtraction implemented by the addition and ones complement will be present over there, and two representations of zeros are there. Still we are going to have two representations as plus 0 and minus 0. Okay, sometimes this may cause some problem for us. Okay, what kind of problem? In the sense, it's going to be a complexation in the addition that's going to be happen over there. Okay, to overcome that problem, we are going to represent